this video, I'm essentially going to be explaining different ways of forcing OLL skips during C-flop solves. I'll be going over a couple techniques that can be used to solve the last lot and OLL at the same time. You should know that OLL skips can't always be done efficiently during speed solves, and it's really only when you have certain cases that it can be done. The first thing I'm going to be talking about is CLS, which is part of MGLS. MGLS is a sub-method mostly used along with C-flop, and it is not an OLL skip method. It replaces the last lot and OLL with two different steps that accomplish the same thing. The first step is called ELS, and it stands for edge step of the last slot. It involves placing the edge of the last slot while orienting the last layer edges. The second step is CLS, which stands for corner step of the last slot. It involves placing the corner of the last slot while orienting the last layer corners. When you watch someone solving with MGLS-F, it may look like they're forcing an OLL skip every solve, but that's not exactly true. They're actually substituting the last slot and OLL steps with two different steps. The reason I'm mentioning CLS in this video is because CLS cases can come up during regular C-flop solves. When you're on the last slot and you happen to have the edge in place, and the last layer edges happen to be oriented, you can use a CLS algorithm to skip the OLL. The chance of having this ELS skip is 1 in 80, which is just a bit lower than a PLL skip, so they actually do happen once in a while. The bad news is that there are a lot of CLS algorithms. There are 104 in total, but the good news is that many of them are actually quite easy. The next thing I'll be talking about is called orientation preserving F2L, and they are probably the easiest cases to recognize. They involve last lot cases where all the last layer cubies on the last layer are oriented. They're easy to recognize because the U layer is almost a solid color. The algorithms solve the last slot while preserving the orientation of the last layer, forcing an OLL skip. There are 31 cases, and you can find them all on Mackey's site, along with other cases that preserve the orientation of the last layer. The last thing, which covers a lot of cases, is row variation. He originally called it RLS for row last lot, but he changed it to row variation or RV because RLS happens to stand for restless leg syndrome. It's for when the last lot cubies are paired in the last layer. The algorithms solve the last layer while solving the OLL at the same time. The subsets are divided based on the edge orientations, and some of the subsets have their own name. When all the edges are oriented, they're winter variation cases, which is probably one of the most well-known ways of forcing OLL skips. When there's a 2x2 square block on the last layer, it's a magic Wondeful case. And yes, it's Wondeful, not wonderful. There's no R in Wondeful. These magic Wondeful cases are inspired by the sledgehammer, and most of the algorithms for them are really nice and awesome. In total, row variation has a total of 216 algorithms, and it is only used for when the pair is on the right side. It's notable that the sub-method isn't meant to replace OLL, and is really only useful when you happen to have the last lot paired this way. It's not efficient to go out of your way to pair the last lot when you can just solve it faster normally and in fewer moves. So in conclusion, if you decide to learn any of these algorithms from these subsets, you should know that they can't always be used in every solve. You can't decide at the beginning of a solve that you're going to be forcing an OLL skip this time, because you might not have a good opportunity to do it. Even when you have the ability to set up certain kinds of cases, if you go too far out of your way, it's not efficient at all, which completely defeats the purpose of forcing an OLL skip. When you force an OLL skip, it's supposed to be efficient. It's supposed to be faster than solving the last lot in one look and then the OLL in one look. Also, there's so many of these last lot plus OLL cases, so anyone can just take a group of them that have something in common and call it something. It's very unrealistic to learn lots of different subsets to force OLL skips because there are thousands of these cases. If you like getting OLL skips and want to learn techniques that will help you get them more often, you should learn the sets that have the nicest recognition and the nicest algorithms, and the ones I've covered in this video are among these. There are a lot to learn, but they're very handy, so if you want a challenge that'll pay off in the end, this is something to do. So that's all for this video. Hopefully it was useful and you enjoyed it. By the way, since a bunch of people asked me to make a Facebook fan page, I did make one. And so feel free to use it to talk to me about anything cubing related. Bye!